In this video, we're going to be connecting all these boxes here, and this is important because this central box is concerning how to approach what? How to approach the specific subject, which is called what? Physics. And a lot of students have had challenges approaching physics, really quite complicated for some people, but it's all about practice, and this is really essential for you to be able to be successful in solving physics problems. And this is going to be focusing on 4 different stages of various physics questions and how to approach them in mathematical and also algebraically. And so let's begin. First is you're going to be looking at a couple of things in terms of, hey, how am I going to, looking at this box, be able to identify an important concept when a question is given. And identification is something that you should be able to accomplish when it comes to looking at a question and solving it. And this here implies that we are going to look at it in 3 fronts. These 3 fronts involves, first, we are going to look at how to go from a physical condition, and this physical condition can actually be a phenomenon that you are going to be experiencing from the question, and how you're going to see how it really matches the other part, which is moving into the physical concept. And this physical concept is how your physics experience in terms of content matter, like for example kinematics, the 5 laws, and many things actually connects to that particular scenario that the question is given. And being able to identify this is something that will be really important enough for you to be successful in physics. Now the other step in terms of identification is what? This other step involves how you'll be able to find the target variable. And target variable means that we are going to be finding a particular number that the question is asking you to find. And this is really crucial because when you look at the question, it says how many, how much, what is, all those W's, which are the 5, are things that you should be aware of or determine. All these are things that you need to be aware of. Either, for example, if you're asked to determine what the intensity of a sound coming from a bird is, that will be really something that is of great interest in terms of, hey, what interesting equations will actually enable you to determine that intensity of sound. Another one that you've probably come across is projector motion, when you kick an object and makes a specific path and it lands, and you're asked to find the v, which is the velocity of that object. That is something also that you might come across. Or you might be asked to determine, hey, what is the size of a particular image that is actually cast on a mirror. And so this is something that you are going to be coming across and really fascinating in terms of solving those questions, not only by one making connections between the physical condition, but going into the concept and how you determine or find that target variable that the question asks you to find. And finally here for identification is listing the known variables. And listing the known variables, some of them might be a deviator, can actually sway you away, or a distraction from the question, but identifying the true known variables will be essential for your success in determining the target variable. And these known quantities or variables can either be what? Can either be expressed, one, algebraically, or it can be expressed numerically. And these two are things that you're going to be aware of as we head into a couple of problem solving questions in physics. So those are the 3 identification styles that you are going to be coming across or exhibiting when it comes to approaching physics problems. The second approach to physics problems in here involves what? In here it involves how to format or what? To set up a question as it is presented in your own way of communication. And this implies first the following. We need to recognize how we can go from our equation of choice to what? How it is properly connected to the problem. And this here is going to be important because it comes with a lot of experience, as you may come across a couple of examples from a textbook or from your classes, and most importantly a lot of practice. And these two are really necessary enough for you to be able to be successful in properly translating that problem to the equation of choice. Now, the next one that you need to be familiar with in terms of format setup is what? This involves how you should be able to correlate properly the variables and how this is going to be necessary for what? The proper equation. What does this mean? This means, for example, if a question asks you to find the speed of a specific wave-like particle and you're given the what? Frequency and the wavelength, you are expected to know that, hey, when you look at the sea of equations, the equation that doesn't fit this criteria is the equation speed is equal to distance over time. Not this at all, but rather you want to use the equation that says velocity or speed is equal to the frequency multiplied by the wavelength. This also comes with experience when you look at the units of various questions and how that might be necessary for you to imply that this equation is the right equation for this particular question given the variables. And so these two do go in hand when it comes to format setup. And finally here is interpretation in your own way. So that means you're translating all the words that are shown in the question that may feel daunting and transcribing it into some kind of a visual media. And this visual media interpretation, I call it, is going to be either in one or two ways. This one involves the following. Either we use a free body diagram and or we use a grid system that has a number line and you start from a particular position and then you change direction and many more things like that you're going to come across when it comes to displacements and distance and velocity and all that kinematics problems they're going to come across in the future. So that is how format setup looks like when it comes to approaching it to physics problems. The next approach to physics, which is the third, is what? In here we're going to be looking at how to tackle a problem, or some people might call it execute, which means that we are going to be doing two things. We're going to be looking at the equation and we're going to see how we are going to be able to transition into the what? The thing that people love, I hope, the mathematical skills. And these skills or strategies comes in various forms that we're going to look at in future videos, either quadratic equation or just solving algebraically for a specific unknown variable. Sometimes you might have two solutions to a problem. It could be using calculus, integration, and many more things in here. But the most important thing is how it connects to one of those things that we looked at here, which is target variable. Usually we're going to be asked to find something which is our target variable, and this is really necessary to be aware of, and this is how this leads to the overall goal of our problem solving in this particular approach to physics. And finally here is going to be looking at what? Either you're thinking about when they say evaluate, or in this case we're going to be looking at what is known as cumulative. And this is usually around the end of your problem solving, where you're going to do a lot of reflection. And this reflection all comes down to, first, how are you going to check your answers? Checking your answers is something that is really important, because sometimes when you have an answer that is too small and you have to be reasonable about it, you're like, how is the size of a telescope, for example, this amount? Does it really make sense in terms of its size? No, I don't think so. Or, for example, reasonably what? Large or big. Like, for example, if you ask that, oh, the size that you got for an atom is what? Is it 10 to the power of 10 meters? You're like, this doesn't make sense at all in terms of the results. So it's really crucial to be able to be aware of this when it comes to how small is your result compared to the reasonable grounds, or how large is your result compared to the reasonable grounds. And that is one thing to keep in mind. In terms of also checking for your answer, you want to think as well about how it looks like algebraically. And when you are solving a particular equation that is an algebraic result, you are going to be able to recognize that, hey, let's say for example you are solving a particular solution and the result is this formula. You want to look at how the V impacts the R, and how your R overall impacts your F, and also your V impacts your F. How does your M, when it comes to the F, which is a net force dependent on the mass, and all those things. You'll be able to thoroughly think through various setups in terms of algebraic expressions and how that will affect your understanding of that particular concept. Now the next and final one is what? We're going to be looking at further questions, and further questions involves what? This involves either you're going to be looking at questions that is more general, or other questions that might be a little bit more challenging. And these are coming from what? These are coming from the problem that you already solved. When you look at a question like this, what other questions that you think you can create that could be a little bit generalistic or can be a little bit challenging? How can you push the boundaries of this particular equation? Does it work in the quantum world, or does it work in a classical sense? All those things are things that you should think about when it comes to approaching physics in this particular video and many more videos to come. So I hope you found this really informative about your approach to physics in terms of identify, format, setup, tackle or execute, finally evaluate or cumulative. If there's any more that you think, please jump down to the comment section and let me hear your thoughts about this or your experience about physics problem solving. We're going to dive into a lot of physics problems and questions and also concepts. So let's join this particular concepts here together. All the same, stay smart as always and believe in yourselves.